Lesson 613. Can we solve side-side angle from geometry? Which, if you were here in class today, you got a little bit of an intro on that. Lesson essential question: how many triangles are there? So you should have figured out that there are two possible triangles given this situation. We already started this problem before I was rudely interrupted. Yeah, about that. In this problem, Katya is trying to determine the distance between her and Ices. What she knows is the angle between Ices and Derek's. She also knows the distance to Derek's and the distance between Ices and Derek's. So what you can see here is that we've started to set this problem up using law of sines in an attempt to find this angle right here of theta. And if I do that, let's see here, inverse sine 30 times the sine of 58 divided by 20. I get a domain error, and if I go to that, there is a problem. The problem here, if I would simplify this a little bit at a time, let's say I just do the discriminant there, which is the part that's inside of the parentheses, 30 sine of 58, and then divide by 20, I have the inverse sine of 1.27. I am not telling you why that is bad. You need to come to class tomorrow with why this cannot be solved. Okay? So, moving on. Next problem. (6-36). Katya's survey instructed to verify that the 58 reading was incorrect. Okay, the angle is actually 28 degrees. So using 28 degrees, can we find the angle at Ices? So let me redraw my diagram. Here's Katya. Okay, Camilla's sister, Ices, and Derek's. Okay, we already knew this angle was 58. We knew that, let's see here. Let's go back one. Forget what the side lengths were, 20 and 30. So we knew this side was 20 and this side was 30. And the new angle we're using there is 28 degrees. So just like we started in class today, we have angle, side, side, angle, side, side. So there's a possibility here for two triangles. So situation one is the one that is provided for us here. So we're going to have angle K. We're looking for angle I right here. So we're going to do sine of 28 over 20 equals the sine of I over 30, which means I is going to equal the inverse sine of 30 sine of 28 all over 20, which means angle I equals 44.7 degrees, so let's say 45 degrees for this problem. There you go, check. Letter A, angle equals 45 degrees. Using 28 degrees for the angle, find the distance from the bench to Ices. So now if we're trying to find the distance here, that will be this side, D. We switch colors here for part B. So we're looking for distance side D there. So we're going to be doing, first you have to find angle D. So if we know 45 for I, we know 28 for K, triangle angle sum. Gives us 107 for this angle here at Derek's. So sine of 107 over D is going to equal the sine of 28 over 20. Cross multiply, solve for D. Okay, so let's see here, 20 times the sine of 107 divided by the sine of 28 gives us 40.7 meters. Last, part C. Katya calculated a distance from the bench to ice to be 40.69. That's what we got. Her friend Carlos laughed and told her that couldn't be possible. That couldn't possibly be right since the measurement put her in the middle of Lake Margaret. What went wrong with Katya's calculations and what is the actual distance? Well, what went wrong is she forgot that there is two possible triangles in this situation. Okay, so once she finds her angle at Ices, which was 45, she also needs to find the obtuse version of this, which we spoke about in class today. And the way that she does that is by taking 180 minus 45. So if she takes 180 minus 45, she'll get the obtuse triangle for the same information given. So that's 135 for I. So I prime, we'll call it, is 135, which means that D prime, which is the alter ego of angle D from the original, triangle angle sum again, so 135 plus 28, and then 180 minus that gives us 17 degrees for angle D. So we repeat this process, but we're going to use 17 degrees here instead of 107 and see what we get for side D. Is it more reasonable? It should be less than 40 meters because that supposedly put her in the middle of Lake Margaret. So we have the sine of 17 times 20 divided by the sine of 28 to give us 12 meters. And that will be your second answer. Again, because there's two triangles when you have angle side side. Or could be two triangles. Next example, 6-37. This is the math notes box, talks about those situations we spoke about today. Here we have no solutions. Okay. Here we have two solutions. That's like the example we just did. And then here, when side A is exactly the right length, it makes a right triangle, and we have one solution. These are all the cases of angle side side and what could result whenever you have that situation. Good to know. All right, Lake Margaret problem ended up with a sine of 0.704. Using a unit circle, draw a horizontal line to show where sine of theta equals 0.74. Okay, there's a little review problem here. So if we know that the sine of theta equals 0.704, it says use a unit circle. So first of all, sine's positive. This is a positive number. So we're talking about quadrant 1 and quadrant 2. So 0.704 is right about here. So we're looking for those two angles. How do we determine those? Well, we do inverse sine of 0.704 to get a theta value of 44.7 degrees. Is that the answer in quadrant 1 or 2? Well, hopefully you said 1 because 44 degrees is in quadrant 1. What would its equivalent be in quadrant 2? Again, we're using the idea of supplementary there, so we're taking 180 minus 45 to get 135 degrees. So theta could also equal 135 degrees. Why does your calculator only give you one of those angles? Reason for that, again, is because our calculator restricts sine from pi over 2 to negative pi over 2 so that it is a function. Open circle, open circle. Okay? Next. Thank you.
You're so welcome.
That was very lame. That's the best you can come up with. The reason there were two possible answers to Lake Margaret problem is that side-side angle, why do they say that? Why don't they just say angle side-side? Is not a congruence method. Given a length for side A, this will be a single side-side angle situation. Since 30 degrees is not, what's up? I have an answer.
So 10-9, I have no idea. I got the area of this sector so far.
Well, you don't, is it asking if by area or perimeter?
What's both?
Well, area of this is going to be So you should be able to find h if you know that that's 60. Because you know what this side is. Hypotenuse is.
No, it doesn't tell you what it is.
Yeah, this is 12. It's a radius.
Oh, I see.
Okay?
Okay.
So if you know the hypotenuse, you should be able to use sine or
Alright.
tangent or cosine. Okay?
I didn't realize you could solve it.
Yep.
like that.
Okay, so find A in the just right situation where there's only one triangle. So what we're looking for there is this situation where A is just the right length. So if that's the case, we have hypotenuse. It now becomes a hypotenuse with a height. Okay, so we're talking about the sine of 30 is going to equal A over 10. So that means 10 times the sine of 30 must equal A. Okay? 10 times the sine of 30 is going to be 5. So A has to equal 5. There you go. There's part A. All right. Angle C in this situation has to be 90 degrees. Because that's what makes it exactly one triangle. Use law of sines to prove there is no triangle if A equals 3. So for part 3 there, or part C, we're using law of sines to show that it can't be possible when A is 3. So what you're doing there is you're saying, okay, well, the sine of 30 over 3 equals the sine of C over 10. We cross multiply and solve. So C is going to equal the inverse sine of 10 sine of 30 over 3. So C equals the inverse sine, 10 sine of 30, we already said is 5. 5 divided by 3 is bigger than 1, and you can't have a sine value bigger than 1 because unit circle only goes from 1 to negative 1. Therefore, 3 is too small. If A is 7, there will be two triangles. Find the two possible measures for angle C. These are shown as ACB and AC prime B in diagram 2 in the math notes. Okay, so what we're looking for here, and again, we've done this. We use geometry to show they're supplementary. We use trigonometry to show they're supplementary. Okay, how many triangles if A was 12? There'd still be two triangles. Okay, and the reason here is this. Okay, this is the generalization. This is how you know from the get-go how many triangles there are going to be. Okay, if using this triangle that we have here, let's say A, and again, this is any general triangle, B, C, okay, and side C, side A, side B. Okay, let's say angle A is our known. All right, so if, all right, one triangle would be when side A equals C times the sine of A. Okay? Is when side C equals, or excuse me, side A equals the sine of A times C. Two triangles would be when A is greater than C times the sine of A. No triangles would be when A is less than C times the sine of A. So there's your three situations. So you can test each problem ahead of time to know what exactly you're looking for. That'd be good information to know. 6-39. And we're probably getting close to running out of time here, so I might have to cut this off. Oh, challenge problem. That's good. Given AC and angle A and ABC, describe the circumstances. Oh, I just told you that. What do you know? Copy it down, bring it to class tomorrow, get extra credit. There you go. That's it.